On this video, I will discuss about z-test. What is z-test? The z-test is another test under parametric statistics which is applied to normally distributed data. It uses two population parameters, mu and the lowercase sigma, where mu is the population mean and the lowercase sigma is the standard deviation. It uses to compare two means, the sample mean and the perceived population mean. It is also used to compare two sample means taken from the same population when the samples are equal to or greater than 30. The z-test can be applied in two ways, the one sample mean test and the two sample mean test. We have here the tabular value of z-test, wherein from the upper row, we have the level of significance at 0.01 and 0.05. And on the leftmost column, we have the tests, which are the one-tailed test and two-tailed test. First, let us have z-test for one sample group. What is z-test for one sample group? The z-test for one sample group is used to compare perceived population mean, mu, against the sample mean, x bar. When is z-test for one sample group used? The one sample group test is used when the sample is being compared to the perceived population mean. However, if the population standard deviation is not known, the sample standard deviation can be used as a substitute. Why is z-test used for a one sample group? Because this is appropriate for comparing the perceived population mean, mu, against the sample mean, x bar. We are interested if a significant difference exists between the population mu against the sample mean. How do we use z-test for one sample group? We use the formula z is equal to the quantity x bar minus mu times the square root of n divided by the lowercase sigma, where x bar is the sample mean, mu is the hypothesized value of the population mean, the lowercase sigma is the standard deviation, and n is the sample size. Example: the ABC company claims that the average lifetime of a certain tire is at least 28,000 kilometers. To check the claim, a taxi company puts 40 of these tires on its taxis and gets a mean lifetime of 25,560 kilometers, with a standard deviation of 1,350 kilometers. Is the claim true? Use the z-test at 0.05. So solving by stepwise method, first is to identify the problem. From the example, the problem is the claim true that the average lifetime of a certain tire is at least 28,000 kilometers? Then, formulate your hypothesis. First is the null hypothesis. The null hypothesis is the average lifetime of a certain tire is 28,000 kilometers. And for the alternative hypothesis, the average lifetime of a certain tire is less than 28,000 kilometers. Notice from our alternative hypothesis that this is a directional test. meaning to say that there is a direction. So it states that the average lifetime of a certain tire is less than 28,000 kilometers. So the direction is it goes down or it goes left. Therefore, that is a one-tailed test. Next is the level of significance. So for our alpha, we'll use at 0.05. Then for the z-tabular value, so we'll be using a level of significance of 0.05 and a one-tailed test, then get the intersection of the two. So z-tabular value is equal to positive negative 1.645. Then it's now time for us to solve using the z-test for one sample group. But before that, let us first identify the quantities. For the sample mean, that is 25,560. For the hypothesized population mean, that is 28,000. For the standard deviation, that is equal to 1,350, and for the sample size is equal to 40. Then, plug in these values into the formula. So that is now Z is equal to the quantity 25,560 minus 28,000 times the square root of 40 divided by 1,350. Then, simplify further. 25,560 minus 28,000 is equal to negative 2,440. Then, square root of 40 is equal to 6.32. Then, divide it by 1,350. Simplify further. Negative 2,440 times 6.32 is equal to negative 15,420.8. Then divide it by 1,350. So the z tabular value now, the z computed value now is equal to negative 11.42. Next is the decision rule. So the decision rule is, if the z computed value is greater than or beyond the z tabular value, this confirm HO. So for us to further visualize, if the z computed value goes beyond the z tabular value, let us plot those values into the graph. So we have here the graph. On the graph, we have the z tabular value of negative 1.645. So that is located on the left part of the graph. It is because that is a negative. Then, on the leftmost part of the graph, we have the z computed value of negative 11.42. So from this itself, the z computed value goes beyond the z tabular value. Therefore, we will disconfirm HO or we will reject the null hypothesis. Then, it is now time for us to make the conclusion. Since the z computed value of negative 11.42 is beyond the critical value of negative 1.645 at 0.05 level of significance, the alternative hypothesis is confirmed, which means that the average lifetime of a certain tire is not 28,000 kilometers. So that is z-test for one sample group. Thank you for watching and I hope you have learned something.